Hello students, welcome back to today's class on basic geometrical ideas. In the last class we have discussed what are basic points, what is a line, what is a polygon, and today we are going to discuss the same thing and we'll try to learn more topics in this. Right, so let's start today's session. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's see what we are going to discuss today. Right, so yesterday we have seen this one. What if I join points without scale? Right, yesterday when we're discussing about a point and all the points together said all this will form a straight line. All these will form a line, correct? But what if there are 2 points and let's say I'm not joining with a scale, I'm joining with some kind of like this symbols, okay? So or in this way, or in this way, whatever it is, however it is, right? So we can join in any way. If you have more points, let's say, if you have 3 points, if you have 4 points, 5 points, so joining all these in different paths, right? So we get different curves, different shapes, right? So even the straight path is also considered as a curve. It's also considered as a curve, okay? So curves. In mathematics, even straight lines are also called as curves. So from one point to one point, if you're joining either in a straight path or in a curvical, in this way, okay? So in any way, a closed or open, whatever it is, n number of points, 2 or 3 or 100 or infinite number of points. So we say them as a curve, right? Curves. Okay, so type of curves, we have closed curves and open curves. What do you mean by closed and what does we mean by open? So you can easily see using these examples, using these diagrams. Okay, closed curves, you can join in any way. You can take a smooth curve or you can take a straight lines and you need to close the figure, right? So you can take a straight line and a curve like this. It is also closed curve. It is completely closed. There is a part inside and outside, correct? Inside and outside. So such type of curves are called closed curves, and here it is an open, right? It is open like this. There is no close, there is no closing in this way. So you cannot say which is open, which is interior, which is exterior. If a point is there, whether it is inside the curve or outside the curve, so we cannot say like that. Understand? So these are called open curves, these are called closed curves. They can be any shape. Not only on the straight lines. Here it is a curve, right? A straight line and a curve like this. So all these are curves. Depending on their alignment, once we say closed or we say open curves. Right? So what else we are going to discuss? The closed curves with same starting and end point. So we have discussed, for example, a circle. I start at this point and again we come to the same point at the end. So we start and end at the same point. For example, at this point I'm starting, I go in a straight line, and again come back to the same point. So we're joining the starting and end point. Curves with the same starting and end point are called closed curves, right? And what happens in open curves? Curve with different starting and ending points. Different starting and ending point. I start here and end somewhere else, okay, and end somewhere else here. So there is no closing position. That means a different starting and ending points, right? So that is one difference between these two. So a closed curve by only line segments. We're trying to discuss about a closed curve using only line segment. What do you mean by line segment? Yesterday we have seen that, right? So this is a line segment which is having a fixed length. This is a line segment. And let's say I close like this. Starting from here, I travel to this point and this point and this point. It is a closed figure. You can see it is a triangle, you know, right? You know what is a triangle? This shape is called triangle. With 4 line segments, I can say it is a quadrilateral. With 5, with 6, n, 10, 100, whatever it is, we are only seeing about closed figure with only line segments, right? A closed figure formed by only line segments is called polygon. So all these are polygons with with 5 sides, let's say, with 5 sides, okay, so with same starting and ending point, it is a pentagon. 5-sided polygon, 3-sided polygon, 4-sided polygon, 5-sided polygon, and they have their own names, right? It is called a triangle, this is called a quadrilateral. What is this called? Quadrilateral. Okay, and this is called pentagon. 5-sided. 5-sided is called pentagon. 6-sided is called hexagon. So, and there are lot many names for that. Right. So, moving ahead, now a polygon can be formed by any number of line segments. Just now we discussed with 3, with 4, with 5, with 6, 10, 100, 1000. Any number of sides you can still form a closed figure only with line segments. Okay, so a polygon can be formed by any numbers of line segment, by any number of line segments. Right, a polygon with 3 sides is triangle. Just now we discussed a polygon with 3 sides. This is a polygon, a closed figure. Polygon means closed figure. You can also try to bring 3-sided figure like this. Okay, 3-sided figure like this. Is it a triangle, the last one? No. Why? Because this is an open figure. Always polygon means closed figure. So this cannot come. Yes, this is correct. Okay, next one. A polygon with 4 sides is quadrilateral. A polygon with 4 sides. Okay, so 4 sides can be in any way, but the point is it should be closed, the starting and ending point. Okay, so we have a square when all the sides are equal, square. We have a rectangle, we have a parallelogram. So all these are different types of quadrilaterals. A 4-sided closed figure, a 4-sided closed figure is called quadrilateral. It is a polygon. Always closed figures are considered to be polygons, right? So next, moving ahead, right, the minimum number of line segments, what we are having here, the minimum number of line segment required for a polygon is 3. Yes, it is correct. We cannot form a polygon with 2 sides. With 2 sides, we cannot close the figure. With 2 sides, we cannot close the figure. We need at least 3 line segments, to close the figure, and then only we can say that it is a polygon. Right? So, moving ahead, a closed curve formed by both the straight lines and curved lines. Straight lines and curved lines. That means I already gave you an example. So, this is straight line and a straight line and a curve like this. So, this is one of the curve. Right? Straight line and a curve from here to here. So this is also one figure. Right? You can have any number of straight lines, 1, 2, 3, 4, 5, 6, and then you can join this one with the curve. Let's say, let me erase that. Yeah, 1, 2, 3, 4, 5, 6, and from here you can come in a smooth curve. Right? So all these are closed figures. You also have open figures that we're going to discuss later. But now tell me, are all these polygons? No. Why these are not polygons? Because polygon means it should come only with a straight line, only with the line segments. It cannot have curves. Okay, only straight line. This is a curved line. Right? A closed curve by only curved lines. So how can you write those type of things? A closed curve by only curved lines. For example, this is a straight line and let's say a curve here. But here all curves. How can we say? So we can say this is one curve and this is one curve and here like this, right? The starting and the ending point should be there. This is all because of curves, but still it is a closed curve. Right? So you can do like this, okay? Right? So all these are closed curves. This is a line again. So you can join this one in this way. It is a closed curve. So this is a completely with curved lines. This is one straight line and one curved line. So we have different types of curves based on the line segments and the curves. Right? So moving ahead, a closed figure separates a plane into three parts. See, whenever I say a closed part, for example, a triangle, when I say this is a closed area, so inside region is there as well as outside region is there. For that polygon or for that curve, closed figure, interior and exterior portions are available. Okay, interior and exterior and boundary. What do you mean by boundary? That means all the points that are there on that particular figure, on the polygon or on the curved surface. Right. So let's say this complete box is a plane. Okay, this complete is plane. You can treat this complete screen as a plane. The screen you're seeing, the mobile. Okay, the screen is a plane, right? So on that plane, let's say you have some circle or some figure like this. So whenever you want to say some point, you can say a point A which is inside. Inside means interior. Inside the surface, inside that region. So it is an interior. A point can be outside. A point B is outside the curve, outside this surface, right? So that can be an outside point. And on the boundary means a point on the curve, right? So we can say that a closed figure separates the plane into three parts: one inside, one outside, and one on the surface, on the boundary. Right. Okay. Interior point. So what is that interior point? It's always inside the region, inside the closed figure. Correct? Any point lying inside the closed figure is an interior point. Any point lying inside the closed figure is an interior point. And you can see here, point A in the given figure is the interior point. A point A is inside the triangle. Point A is inside the triangle. Right. The same way, exterior point, the point in the plane lying outside the closed figure. You can see here, point A is outside the closed figure. Correct? So if that point is outside, we say it is an exterior point. And we have a point on the boundary which is called boundary point. You can see that point is on the triangle or on the closed surface. Right? So we can say that it is a boundary point. The point which is external is called exterior point. This is interior point, and this is called boundary point. Right? So let's see what else we can see here. Okay, so we have few things here: a simple curve and a complex curve. What do you mean by this one? What do you mean by simple curve and what do you mean by complex curve? Can you tell me some examples? This is a simple curve. Although it is a straight line, it's a curved line, so it is a simple curve. Okay, we just start and we end at some point. But are we coming to the same point again in our journey? For example, there is a point here and we are traveling like this, in this way, and in this way, coming till here. Are we touching any other point again in our journey? Here at least. Okay, so here is our point. Are we going here and again coming back and again going and again coming back? No, we are not doing like that. We are just moving in one complete circle, right? We are not touching the point again and again, but there are some points, there are some things here. These type of things, when you're drawing, you need to come to some point again and again, right? For example, if you're starting from here, okay, you start from here, go from here, next go like this, and let's say you're coming like this, okay, and again you go like this, and again you come to this point you're touching again. Although you can draw without touching also, like this, okay. So this is starting point, and this here like this, and again like this, okay. But the thing is, you need to understand that we are coming back to that point again and again. So I'll draw one more figure, okay. Like this, let's say. Okay, so what happened here? We are again touching this point at some point, correct? In our journey. You may able to draw this one without lifting your pen, that's okay. But when in my journey, when I'm starting from the first point to the last point, I'm touching some points again and again. So such type of things are called complex curve, right? Complex curve, more complex curve like this, okay? So if I draw like this, okay? So it's a complex curve. some points you again come and join, you can again come and meet, right? There is no specific shape that we can define that it is a complex curve. No. If we are joining some points again and again in our journey, then we can say it is a complex curve, right? So let's move forward for some examples. Simple curves are the curves that do not cross themselves, okay? But here, complex curves are the curves that cross themselves. You can see like this, okay? The figure we came to here. So we are crossing at this point, right? But in the simple curves, we are not crossing its journey. We are not coming back to the same point again. We are coming back to the same point sometimes, right? So that is the difference between simple and complex curves. Next, alphabet G is a simple closed curve. Alphabet G is a simple closed figure. Is that correct or wrong? Okay, or else we'll try to write as it is being printed. Okay, like this. Is it a simple closed curve? Is it a closed? No, you can see here. Our first point and the end point are not the same. So first thing, it is not closed. It is not closed. But is it simple? Yes. It is simple because it is not crossing itself. We are not coming to the same point again and again, right? So although it is simple, it is not closed. It is simple, but it is not closed. So we can say that as it is not closed, it is not simple closed, right? So answer is no. Answer for that will be no, right? So let's move forward for the next question. Alphabet M is a simple closed curve. Alphabet M is a simple closed curve. Again, I can see the starting point and the ending point are not the same. The starting point and the ending point are not the same. So we can say that it is not a closed curve. Okay, letter O. Okay, the answer for that will be no. It is not a closed figure. Letter O, is it a simple closed? Letter O, simple closed, right? It is simple curve and it is a closed figure, correct? Q. Letter Q, let us say. Letter Q, you write it like this, right? We need to come and we need to meet with the curve cross itself. So it is not closed first of all because this part is closed but this is not closed again, right? So based on the shape, based on the figure, based on this parameters, we need to discuss whether it is simple or complex and closed or open, right? Although this part is closed, but still there is a part which is open outwards, so it is an open, right? So let's move forward. Alphabet B is a complex closed curve. Alphabet B is a complex closed curve. Is that correct? Yes, right? It is a complex curve, correct? Is it closed? Yes, it is closed. You can see that the initial and the ending point. Let's say this one, the initial and the end points. I'm starting with this point and I'm ending at that point. Yes, we can say that it is a closed curve. You can see that, and it is a complex. It is coming and meeting again and again, right? So we come to B and again go back to the same point, touching few points and then go down, right? So answer for that is yes, it is a closed complex curve. It is a closed complex curve, right? So let's discuss about what is an angle. We started discussing about a point, and then we discussed about a line, then we discussed about curves and also open, closed curves, complex, simple curves, right? Following to that, let us try to discuss what is an angle. In geometry, angle is very, very, very important because in the higher geometry, when you go into higher classes, every question, whatever you're discussing, will be somewhere related to some angle inside that. Okay, so let's try to discuss what is an angle. An angle is formed when two rays, we discussed what is a ray, which has one starting point but no ending point, right? An angle is formed when two rays originate from the same point. An angle is formed when two rays originate from the same point, correct? Okay, so that means for example, let's see the diagram. Okay, so from this point which is called vertex, one arm is this one and the other arm is this one, or one ray and the second ray. An angle is formed when two rays originate from the same point. That point is vertex and the rays are called arms. The rays making an angle are called arms of the angle, and the common point is called vertex. So this common point is vertex and these two are called as arms. So this measurement, whatever we measure in whichever system we are measuring, sometimes we measure in terms of degrees. In higher classes, as you go on, you also have some kind of radians. So there are different systems to measure that. We are going to discuss that in the coming classes. Okay, so this measurement like 30 degrees, 40 degrees, 50 degrees, there is some particular measurement and units for that. Okay, so this is called angle. This is called angle. Angle is formed between two rays, not between two line segments, not between two lines. We generally go with two rays, because we need to find the angle at this common point, which is a vertex. Although you discuss an angle between the lines, it means that from this point we are measuring one ray and the second ray, and there we are finding the angle, right? So that is what we are saying about rays. You can try to find the angle anyway between any two curves. The point is, at that particular starting point, from there we need to find the angle. Clear? So what else we are going to learn today? The angle in the figure is represented as, so here we are trying to find the angle. So this angle ABC, we write this as angle ABC. That means we are starting from A and reaching to C, touching the point B, and at that point B we are trying to find the angle, right? This can also be written as in this way, angle CAB. Starting from C we are going to CBA. Starting from C we are going to B and then we are reaching A. So this angle is also called CBA. So angle ABC or angle CBA both represent the same thing, that we are going to find this angle, right? So what else we are going to learn today? So the remaining things, what is an interior of an angle, what is exterior of angles, okay? So all these things we are going to learn in the next lecture, about angles and circles and different parameters of circles like radius, circumference, diameter. So all these we are going to cover in the next lecture, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So now we'll be discussing about volume. Okay, my name is Shashan Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So have you ever wondered about what does liter mean? Like all of you would have bought water bottles, right? Yes or no? Bisleri and all different company bottles. And there will be of 1 liter. 1 liter of water bottle, 20 rupees. Normal cost, right? So but what does liter in 1 liter refer to? What does that liter refer to? So see here, we know when we say 1 meter, we know that 1 meter will refer to length. Meter is a unit of length, so it will refer to length. But what does liter refer to when you say it is 1 liter? Whose unit it is? Is it the unit of length, area, or anything else? And the answer is, it is the unit of what? Unit of volume. So we already have a basic idea of what volume is. So what is volume? Volume is nothing but space occupied by an object. We'll have a simple example here. Look at this first example, this first one. I have taken a container and that container has water. And this is the level of water. This is the level of water. Until here, you have the water. Simple. Now, if I look at the second case, in second case, what we are doing is, we are taking a stone, we are tying that stone with a thread, and we are immersing it, dipping it in the water. And what happens? You can clearly see that the water level rises. Water level rises. Now, why does it rise? That's the question. Why does the level of water rise? Can you tell? Yeah, because the stone is occupying space. The stone will occupy some space. That is the reason why the water level rises. And how much will the volume occupied by the stone be? This is the extra volume of water, extra space occupied by water. Yes or no? Here, in the first case, no stone, only until here. The second case, the water level has risen. That means the extra space occupied by water, where does that extra space come from? It comes from the volume of the stone. So this extra volume, this extra space occupied by water is nothing but the space occupied by the stone. And what do we call the space occupied by the stone? Volume. We call it as volume. Simple. The space occupied by an object is called its volume. Understood? Good. Let's continue. Now, when it comes to volume, every object occupies volume, right? So when it comes to a cube, so first of all, what is a cube? A cube is a box-like shape. Okay. So here it has how many faces if you count the number of faces? 1, 2, 3, 4. Right. And then one is facing us and the other is that side. So 5 and 6. So it has a total of 6 faces. If I want to draw it and show it to you, let me draw and show it to you. This is a square. This is what a square. Simple. But it's not yet done. This one face, one square you can see. This is also a square, not clearly visible because it is inside. So we are drawing a 3D shape, a 3-dimensional. Another one here. So for now you can see how many shapes? 1, 2, 3. But I'll draw another one now. See. Now if you count them, I'll just shade everyone individually, so you have to count them carefully. Okay. So first comes this. This one side, everyone, this one face, not side, that is what? One face. Right? Which is what? This one face. Good. Now, this another face. Another one. I am also shading it. Another one. Okay. Now, let me draw the others. What is this? This is also another one. Yes, another square. So in total, how many until now? Until now we got 3. Until now we got 3. 2 yellow, 1 green. Then I'll again have another one. I think I'll have to erase this. So let me erase the ones that I have already drawn. So 3 we got. Now I'll draw the others. See, this is the other one. So how many now? We got how many? 4. We got how many? 4 until now. But is it done? No, we still have much more to do. See that, okay? 4 are done. 4 are done. Now, this is the top and this is the bottom. So how many total? We have 6. If we count all of them, we get how many? We get 6. So let me just write them down. 1, 2, right, 3, 4, 5 at the top and 6 at the bottom. So how many? 6 faces, and each face will be a square. Each face will be a square. That's the important part. Okay, you just have to know a few points. What are they? A cube has how many faces? 6 faces. Right, another important point, each face is a square. Each face is a square. So just remember these points. In detail, you will learn those in maths. Need not worry, but I'm just giving a simple idea. So that we can go into the, what? We can go into the volume occupied by a cube. There's a simple formula for that. I'll go into it. Before that, one more interesting point of a cube is, every side will be equal because every face is a square. In a square, all the four sides are equal. So if this is 10 centimeter, this will also be 10 centimeter, this will also be 10 centimeter, this will also be 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter. Whatever side you come across, all the sides will be equal in a cube. All of them. In fact, there are many others. The interesting thing is all the sides will be equal. All sides are equal. All sides are equal. And what is the formula for volume of a cube? It is nothing but one side cube. So for this example, it will be 10 centimeter whole cube. That means cube 3 times. It is 10 centimeter into 10 centimeter into 10 centimeter. That's what cube means. Here the power is 3. We discussed it. Power is 3. It means that it has to come 3 times. 10 into 10 into 10. Understood? Okay. Simple formula. Remember this. Volume of a cube is equal to one side, then cube. Okay? Good. Now, let's look at this. So what is the formula for volume of a cube? It is A into A into A. That is nothing but A cube. A is nothing but the side length. Now why is the formula important? It is important so that we can understand the unit of volume. How? If I go into the SI unit, I'll go into the SI unit. But how do we get the SI unit of volume? For that, what we will do is, we'll look at the units of A. See, what is A? A is the side length. And what is the SI unit of length? Meter. It is meter, again meter, again meter. You are multiplying meter 3 times. You are multiplying meter 3 times. What does that mean? It means I can say the SI unit as what? Meter cube. So the SI unit of volume is what is meter cube. That is the point that we need. Understood? So let's summarize what we have learned. We have learned that volume is a space occupied by an object. Volume of a cube is equal to A cube, where A is one side or the length of one side. And the SI unit of volume is meter cube. Good? Okay, so here we have understood about the SI unit is meter cube. Now there are other units also. Some of them are, you can see, centimeter cube is another unit. Liter, that which we discussed at the beginning. Liter is a unit of volume. Then you have milliliter. Let's understand all of them. First, again the formula, volume of a cube is equal to what? A cube, right? A into A into A. Now if I take A in terms of centimeters, not meters, not the SI unit, but I'll take it in terms of centimeters. So for A, centimeter for A, centimeter for A, again centimeter, that means you're multiplying it 3 times. Centimeter into centimeter into centimeter. 3 times. So what does that become? It becomes centimeter cube. It becomes centimeter cube. So meter cube was the SI unit, centimeter cube is another unit. Okay, then comes liter. The symbol for liter is nothing but L, small l. Now, you need not know how it came and all. All that you have to understand is 1 liter is 1000 centimeter cube. 1 liter is what? 1000 centimeter cube. And again, just remember this, whenever you come across milli, milli is 1 by 1000. It's like kilo. What is kilo? Kilo is equal to 1000, but milli will be equal to 1 by 1000. So when we say 1 milliliter, it is, what is milli? 1 by 1000. So it is 1 by 1000 liters. 1 milliliter is what? 1 by 1000 liters, or you can say 1 liter is equal to 1000 milliliter. Okay, and if you compare these two, 1 liter is 1000 centimeter cube, 1 liter is 1000 ml. See, the only thing that changes is this. Between these two, 1 liter 1000, 1 liter 1000. That means centimeter cube and milliliter should be equal, and in fact they are equal. 1 milliliter is equal to 1 centimeter cube. So all these are unit conversions. All these are what? Unit conversions, and what you have to remember is this. The SI unit of volume, meter cube, done. Other units, you have centimeter cube, you have liter, and you have milliliter. 1 liter is 1000 milliliter, and 1 milliliter is 1 centimeter cube. So whatever is there on this page regarding the units, you have to remember that. Okay? Good. Let's go into a simple question then. What is the volume of a cube of side length 1 centimeter? The side length is 1 centimeter, then what is the volume of the cube? Everyone try solving it. We are talking about a cube, not of any other body, about a cube. So what is the length of the side? So what is the volume? What is the volume of the cube? Yeah, everyone, what will the answer be? Very simple formula. Volume is equal to, or volume of a cube. We are not taking any other shape, we are taking a cube, is equal to a cube. What is A? A is side length, or length of one side. Length of one side. And what is A given as? A is given as 1 centimeter. That means A is equal to 1 centimeter. So all that we have to do is A cube will mean A into A. Power is 3 times. Then in place of A 1 centimeter, then again into 1 centimeter, then again into 1 centimeter. Now if you look at this, it is 1 into 1 into 1. What is 1 into 1 into 1? 1. Right, so it is 1. But if I look at the unit centimeter into centimeter, yes or no? Look at that. So centimeter is coming how many times? 3 times. So if it is 3 times, how will you write it? You will write it as power 3. That is 1 centimeter power 3. 3 power is called cube. So 1 centimeter cube, or 1 cubic centimeter. Okay, centimeter cube or cubic centimeter. Okay, simple, done. So if the side length is 1 centimeter, the volume of the cube will be 1 centimeter cube. Simple? Okay. Now let me show you something interesting. Note. Meter is the length of what? Or the unit of what? Meter is the unit of length. Then meter into meter, which is equal to meter square, is the unit of area. Is the unit of area. Then meter into meter 3 times m to the power 3, or cubic meter, it is the unit of volume. Can you notice anything interesting? Yes. In length you have only 1 m, in area you have 2, in volume you have 3. So based on this, the formulas will come. Ultimately they have to satisfy this. Right? They have to satisfy the units, the multiplication. Okay? So length, area and volume, the SI units, meter, meter square and meter cube. Okay, that was one interesting point. Now let's continue. Another question for us. This I'll leave it to you. A big box is filled completely with 15 identical cubes. And what does identical mean? Identical will mean the similar cubes. Exactly same. Of side 1 centimeter. Each cube is of side 1 centimeter. And how many cubes are there? 15 cubes. All of them completely fill a box. What is the volume of, not the cube, but the box? The question should be, what is the volume of the box? So I'll give you 1 minute. So please solve it, everyone. I'll give you 1 minute, so please solve it. And to get the volume of the box. In that box, you have a total of 15 cubes. So it would be a simple, straightforward multiplication. So please do it. "25 seconds more." "10 seconds more." Three, two, one. The time is up. Now let me solve it for you. So imagine this. You have a box. Just a minute. You have a box. Okay. And in that box, you are filling it with what? You are filling it with small cubes. You can think of this one cube, then another one, then another one, then another one, right? Upon that another one, another one, another one, another one, another one. I am showing here how many? 12, but I think there are how many? 15 in total. So it is completely filled with how many cubes? 15 cubes. So what will the total volume be? One cube, one small cube will have how much volume? Side is 1 centimeter. Just before this we got that. If the volume of a cube of side length 1 centimeter is 1 centimeter cube. That means here I can clearly say that, just a minute. Yeah, I can clearly say that one small cube has a volume of 1 centimeter cube. Just a minute. One cube, what is the volume? 1 centimeter cube. Because each cube is of side 1 centimeter, so one cube will have or will occupy a volume of 1 centimeter cube. But if you are filling it with a total of 15 cubes, one cube occupies volume 1 centimeter cube. So 15 cubes will occupy 15 centimeter cube. That's it. So 15 cubes will occupy a volume of 15. How, sir, how 15? Just multiply. Here you had one cube, right? Or else we have everything here. One cube, 1 centimeter cube. But when you multiply with 15 on both the sides, 15 into 1, 15, 15 into 1, 15. That's it. Very simple calculation. Right? So there are total of 15 cubes in the box, completely filled. That means the box can occupy how much volume, or the box has a volume of 15 centimeter cube. Okay, that's a crude way of measuring the volume. Are there any other methods? Yes, there are. Let's go into a few of them. One is using volume measuring instruments. So using volume measuring instruments, we can measure the volume of liquids as well as solids, both of them. So let's go into how to measure the volume of liquid. But here you can clearly see it's a cylinder. The shape is like a cylinder, that's the reason. This is shaped like a cylinder, yes or no? What is a cylinder? Cylinder will be like this. This is a cylinder. So it is shaped like a cylinder. That is the reason why we call it a cylinder. It's a measuring cylinder. It's what? A measuring cylinder. And look at the values. It's clearly written already. If you look at the values, here they start at 0. From 0 they go to 100. And what are the units? Milliliter. Not much, not huge. I know it's a very small volume to measure, but yeah. So you can have different measuring cylinders of different capacity, but here the capacity that we can measure. the volume that we can measure, or the maximum volume that we can measure, is 100 ml. Is what is 100 ml, but 1 ml is 1 centimeter cube. See, 100 ml, which is nothing but 100 centimeter cube. Generally, can you have measuring cylinders of different volume capacities? Yes, you can. We can always make it. Not an issue. Okay, good. Then you have measuring beaker also. Have you seen any one of this? Look at the image. Have you seen any one of this anywhere? Anywhere at all? Yeah? If you are from a village or a town, or if you have ever visited a village or a town, then you can easily recognize them. Because it is mostly used by milkmen. Right? The people who deliver milk to our homes. Not in packets. Not in packets, but who directly deliver milk to our homes. They use these jars to measure what? To measure the volume of milk. That's why we call it as what? Measuring jar or measuring beaker. Okay, again they can be of different capacities. You can see 500 ml, 200 ml or 500 ml. Different shapes, different volume. Again, they are used in kirana shops also. If you ever go to a kirana shop, you can ask the shopkeeper, he or she can show it to you. They'll also use this to measure the volume. So for milk, for oil, etc. 550 ml, 100 ml, 200 ml, 500 ml, 1 liter, different volumes are possible. Depending on the usage, you will get different measuring beakers, different measuring jars easily. Okay? Okay, that's good. So now let's see how to use a measuring cylinder properly. It's simple, look at this. First of all, when you take the measuring cylinder, it's just a cylinder. So what you do is you have to wash and dry the measuring cylinder properly. Dry it. There should not even be one single drop of water or of any other liquid. You have to dry that properly. Dry it. Now place it on a flat surface like a table and pour the liquid. Whatever liquid you have to pour, whatever liquid you have to measure, you have to pour it slowly without splashing. Now you have to wait for it and wait till the liquid becomes stationary. It does not does not dance around, does not oscillate. Now whenever you take water or you pour it in a bottle or any bucket anywhere, you'll see that the surface slightly splashes, it oscillates up and down, right? That should not happen. You have to wait for some time, and when you wait for some time, it will become stationary. And if you look at the top, a slight curve will be formed if you are careful. If it's a very thin cylinder, measuring cylinders will be thin, it will not be a straight line, but it will be what? It will be a slight curve. Do not get confused by it. That's the nature of the liquid. It will be in that way. You need not worry. Okay. Then once it is dried properly, you have placed it on a flat surface, poured it. After that, what you will see is, you need not do any calculation and all. Just directly look at the top of the surface. This is a surface, the top. Whatever reading it gives you, that is the answer. But while you take the reading, you have to keep your eye on the same level. You cannot be seeing from here. No. This is wrong. You cannot be seeing from here. That's also wrong. You should keep your eye on the same level as the surface. It's like if this is surface, I have to be here. Exactly. Then you will get the correct reading. Read the level by keeping your eye in line with the level of liquid. And then you take the reading. Simple. Even without me telling it, you will know how to use a measuring cylinder. Yes? That's it. Good. Then you can again go with measuring measuring using a measuring beaker also. It is used to measure smaller volume from a larger volume. Wash and dry the beaker, first one, as always. Now here, for this what you will do, you will not pour the liquid in this, but this you will insert or dip in the liquid. If you have to measure the volume of, let's say, some given amount of milk, then you dip this in the milk, then take it out. Dip it in and take it out, and it should be completely filled. Okay, that's the reason. Immerse the beaker in the liquid bucket so that the beaker is completely filled. It should be completely filled until here. Look at the image. Until the top, it should be completely filled. Now pour into another vessel without splashing. So you have one bucket here, let's say. You have one bucket here. This is completely filled, not completely, but let's say it is filled with liquid, and you have to measure it. This will be an empty bucket. So from here you take it and pour it in this. You dip the measuring beaker in this liquid, take the amount of water, all the liquid, then dip it in the empty bucket. That's one. Then you do it again twice, then you do it again thrice, then you do it again 4 times, 5th time. You keep on doing it until all the liquid will go from this basket to this basket. Okay. So here the volume is how much? Volume of one time or one beaker is 500 ml. So if you take one time, when you first take the liquid from this, you are taking it completely. So how much are you taking? 500 ml. Time you take 500 ml and pour it in this 500 ml. Then second time you again pour some more. That's again 500 ml. So what is it total? 1000 ml. Then you again pour another 500 ml. Then total will be 1000 plus 500, 1500. Simple. Right, so this way, you have to count the number of times you do it. You have to count the number of times you do it. So, if you do it 10 times, that means the volume is equal to 10 into 500 ml, which is what? 5000 ml. I'm giving an example, okay? 5000 ml, just an example. Understood? Okay, so that's how you measure volume of a liquid using what? Using a measuring beaker. Simple. Measuring cylinder is done, measuring beaker is also done. Then we have other things also. Sir, we learned about how to measure the volume of a liquid. Good. But how do we measure the volume of a solid? We'll see that also. It's again very simple. You can do that using a measuring cylinder itself. How? Simple. If you have to measure the volume of a stone, take the stone, tie it with a thread as shown. Simple. Tie the object to a thread and dip it completely in water, completely in the liquid. So when immersed in the liquid, volume of the liquid displays. So this is the extra volume of liquid. Why does the water occupy extra space, extra volume? Because this volume is what? Volume of stone. What is that? That is volume of stone. So if you can calculate that, you will get the answer. But how do I calculate that volume of stone, or what extra volume occupied by the liquid? How? Let me show it. This is how you do it. Okay, see, initially the volume here is how much? It is given as, let's say, V1. I'll take an example. We'll talk in terms of numbers. So here, let's say it is 60 initially, and now it has become 80. So initially, when there was only water, the reading was 60 ml. But now when there is water, the reading is 80 ml. In the second case, what is extra? The stone is extra. Here there is no stone, here there is stone. The stone is occupying extra space. How much extra space? This much extra space. But how do I get that? Very simple. From 80 ml, if I subtract 60 ml, whatever I get will be the volume of stone. The extra space occupied will be what? Will be the volume of stone. For the volume of solid, in this case, you have a simple formula. Just subtract the readings in both the cases. Just subtract the readings in both the cases. Okay. A simple question for us. Just look at this and we'll end the class. When a stone is lowered into a measuring cylinder, the volume is 9 ml. Okay. But the volume of the stone is 6 ml. Find the initial volume of water in the measuring cylinder. Let me do it. Let me first write down the given information. Okay, now let's just try the image. This is the cylinder. Two cases. Here only water, volume V1. Here volume and the water and stone, V2. We know that volume of stone, we know the formula for volume of stone, which is how much? V2 minus V1. You just subtract the readings. But what is given here? Volume of stone is given as 6 ml. When a stone is lowered into a measuring cylinder, the stone is there in the cylinder, then the volume is 9 ml. That means in the second case, V2 is 9 ml. But what we have to find out? Find the initial volume of water. We have to find out V1. Simple. Use the formula Vs is equal to V2 minus V1. Vs is how much? Vs is 6. V2 is how much? 9. 9 minus V1. So what will it be? V1 will be equal to 3 ml. 9 minus 3 is equal to 6. So here the volume of the liquid is how much? It is 3 ml. That's it. Simple, right? Good. Okay. So that's it, everyone. We learned about volume. We also learned about how to measure the volume and the units of volume. So please practice. It's a very simple topic. Okay. Thank you. Thanks.